Welcome student in my third class. In the previous two classes I have described you about numerical integration and some topics about trapezoidal rule, and I have given you the PDF copy of the numerical problem of trapezoidal rule. And in the previous class the last problem was a river is 80 meter wide. You know that, but I will first again describe in quickly manner. The depth d in meter at a distance x. Now you see that it is the cross section of a river, and this river is 80 meter wide. So here we want to find out the cross sectional area of the river. This problem is very much applicable in survey project like hydrographic survey or any other thing. Here you have to find out the cross sectional area of the river. It is the curve, like it is fx is not known. Lower limit is 0, upper limit is 80. Why it is 80? As the river is 80 meter wide. So we are starting from 0 and ending at 80. If you integrate this unknown function, now see here, unknown function from 0 to 80 fx dx, as the base axis is x axis, then you will find out the cross sectional area, but the function is unknown. But this function has different functional value at different point starting from 0. All the points are equispaced. Why it is equispaced? 0 to 10 the gap is 10, 10 to 20 gap is 10, and in different value of x, that is we are starting from one bank at a distance 0 to 10 meter. We are going 10 meter. Then we are from using a bamboo or a measuring tape, we are getting that 4 meter depth. After we are going in 10 meter interval, that is 20, and getting the depth 7. So in different value of x we are getting different value of depth, that is the functional y, and we are using trapezoidal rule here. So when we apply trapezoidal rule, the formula is very easy, h by 2. Here h value is 10. Number of interval. Now see here, number of interval. How many points is available? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the interval is 8. So I am writing the number of interval is 8. And the first functional value is 0. Last functional value is 3. So we are using the formula. Step length is 10. It is by 2. Then first functional value is 0. Last functional value is 3. Plus 2 into remaining other means 4 plus 7 plus 9 plus 12 plus 15 plus 14 plus 8, and after that we will get using a calculator. See here, using calculator, 4 plus 7 plus 9 plus 12 plus 15 plus 14 plus 8, all is multiplied by 2 plus 3, then into 10, and it is divided by 2. So the cross sectional area of the river is 705 square meter. So it is easy enough. Now I will briefly describe you Simpson 1/3 rule. It is another rule, Simpson's 1/3 rule. Total elaboration of this rule is not required for your syllabus. Just remember the formula. It is very easy. Simpson 1/3 rule is only applicable when the number of interval is even. Number of interval is even. That means we can't apply Simpson 1/3 rule if and only if the interval is even. If the interval is 3, it is not possible. If the interval is 4, we can apply Simpson 1/3 rule. Why we need Simpson 1/3 rule? Now previously you know that it is the function, it is lower limit, it is upper limit, we are dividing into some slices. In trapezoidal rule we are joining the upper top points by straight line, but in Simpson one-third rule it is joined by parabola. Now if there are 3 points, we can draw a parabola. To draw any parabola we require 3 points, particular 3 points. So here by 3 points we are drawing a parabola. With these 3 points we are drawing another parabola. So for drawing a parabola we require 3 points but 2 interval. So the number of interval should be even. But here this 2 point is not joining by parabola. So remember, in Simpson one-third rule the main concept is number of interval is even and the point are joining by parabola, and is more correct than trapezoidal rule, as in trapezoidal rule they are joining by straight line. Now as it is a parabola is a curve, so the required area is more correct, and the formula is ISC. S means Simpson's one-third rule, C is composite figure. In the trapezoidal rule we are using h by 2 and here we are using h by 3. That is 2, it is 3. Again first plus last, n number of interval, so the last interval is yn. Now you should remember, in the trapezoidal rule that was 2 into remaining other, here 2 into even points. What are the even points? 2, 4 up to yn minus 2. Why it is n minus 2? Now think that if the interval is 10, last point is y10. So we will start from 2, 4, 5, 6, 7 up to 8. So it is n minus 2. And 4 into odd points. Odd point means y1, y3 plus dot up to yn minus 1. That is, if the total number of interval is 10, we will ending at y9. So in the previous problem, if we do with the help of Simpson one-third rule, then what should be the solution? Now see here, ISC h by 3. First, total number of interval was 1, total point was 1, 2, 3, 4, 5, 6, 7, 8, 9. Interval is 8. So we can apply Simpson one-third rule. Formula is h by 3. First value was 0. Last value was 4. 2 into even point. Last value is 3. Last value is 3. 2 into even point. Even point means y2, that is 7. Then y4, that is 12. Then y6, that is 14. Plus 4 into odd point. Odd point means y1, y3, y5 and y7. So after that we will get it is very easy, 4 into 4 plus 9 plus 15 plus 8 plus 2 into 7 plus 12 plus 14 plus 3 into 10 divided by 3, 710. So it is 710 square meter. So it is saying that the Simpson one-third rule is more correct. In examination there are many problems. You can apply trapezoidal rule or Simpson one-third rule, but in various problem it is written that Simpson one-third, you apply Simpson one-third rule, but you should remember that the number of intervals should be even. So for today's class I am describing you total trapezoidal rule and Simpson rule, and I describe this problem, and if you understand then I will give you tomorrow a assignment where you should practice Simpson and trapezoidal rule, and after that I will give total model question paper about this numerical integration. Thank you.